Hello, welcome to this video. This is 5-4, and in this video we're going to talk about the extreme value theorem, which will lead us right into the candidates test, how we find absolute or global maximum and minimum values for functions using calculus. Alright, so previously we have used the first derivative test in order to find local extrema of a given function. However, local extrema may or may not be the most extreme value of a function over a given interval. The greatest value of a function, f of x, is called an absolute, or sometimes a global maximum. And the least value of a function is called the absolute or global minimum value. And here are some visual examples of this. You can see the absolute maximum here at point A, and you can see the absolute minimum at point B. Now, B and C are also relative minimum and maximums, and it is possible to be also a relative minimum as well as an absolute minimum. Important note. Both types of extrema, relative and absolute, are important in calculus. Since both are types of extrema, we might expect these processes, in order to define them, to be similar. But it's important to note that generally we cannot use the first derivative test to find or justify absolute extrema, because they are different tests and approaches. Do you think that every function has an absolute minimum or an absolute maximum value? That is a question we're going to go ahead and answer, talking about the extreme value theorem. So, example number 1. They say, for each statement below, sketch a graph that satisfies the given information if possible. Otherwise, write not possible. So here they say the function f of x attains a global minimum, but not a global maximum on the interval 0 to 5. Okay, 0 to 5. So I'm going to make an axis here, and I'll say that this is 5. And I'm going to go ahead and make myself an asymptote here. And we want a global minimum, so a lower value. Okay, so there's 1, and as well as on the interval 0 to 5. So I'll do this side as well here. Okay, so this example, we have a minimum, a global minimum, but not a maximum, because our function values keep going here at, I don't know, we can call this whatever we want, 3. But there's an example of where it does not have a maximum. Next one, the function g of x attains an absolute maximum, but not an absolute minimum on the interval -4 to 2. And on this one, I'm going to go ahead and I'm going to plagiarize just a little bit here. I'll say this is 2, this is -4. I'll give myself this example again, where I have an asymptote and I have an absolute maximum. We'll say this decreases here, and then here also an absolute maximum, and it's decreasing, approaching the asymptote. Okay, so those are examples where we don't have an absolute max, we don't have an absolute minimum. Now here, the function h of x attains a minimum at 2 different values of x, but only one maximum on the interval 1, 8. Okay, so I'm going to go ahead and draw my axis here, and there we go. Okay, 1 to 8. 1 to 8. Okay, so I'm going to go ahead and let's see. 2 different values of x, we have a minimum. So I'm going to go ahead and I'm going to do a trig function. Let's do something like this. And there we go. We have 2 values that have the minimum, global minimum at these 2 values, and then 1 value where we have a global maximum. Okay? All right, and then the last one. For 0 is less than x, which is less than 4, the function k of x is continuous but does not have a minimum or a maximum value? Continuous, but does not have a minimum or a maximum value. Well, in this case, this is the one that is not possible. I cannot draw a graph if it is continuous on a closed interval that does not have a minimum or a maximum value. Now, why might this be? Well, this is going to lead us into the extreme value theorem, also known as the EVT. So if f is continuous on the closed interval a to b, then f has both an absolute minimum and an absolute maximum value in the interval. So this is another one of our existence theorems that we're going to go ahead and use to answer questions about functions. So every theorem has conditions, and these conditions must be met in order to utilize the theorem. Okay? If they're not met, then we cannot apply the theorem, and we must consider another approach if possible. Okay? So again, for the extreme value theorem, what are the conditions? Well, the conditions are it must be continuous, and it must be on the closed interval. Okay, so if these conditions are not met, if they are not met, or sorry, if they are met, what are we guaranteed? We are guaranteed f has a absolute max and minimum. Okay, so if I can satisfy these two conditions, they are. What if they are not met? Well, if they're not met, then I can't guarantee anything. Okay. Now remember, these theorems where we guarantee something, this is called an existence theorem. An existence theorem. And we talked about two other ones before. We first talked about the intermediate value theorem, where I guaranteed a value in between a certain set of values, and the mean value theorem, which is where we said I rock is equal to A rock. Okay, so the extreme value theorem, and just think extreme values, that's a maximum and a minimum. Okay, so we're going to go ahead and use this table below, and we're going to go ahead and look at it. And kind of, this is one way visually to kind of help build and scaffold the idea of the existence, or the extreme value theorem. So, the first one here, f of x. Is f of x continuous? Well, here I have a smooth curve. Yes, this is continuous. Can I go ahead and apply the extreme value theorem? Well, is it on a closed interval? Am I including the endpoints? Yes, we can go ahead and do that. Does f of x have a minimum and or a maximum? And I'm going to go ahead and kind of put this here. Yep. I have a maximum here and a minimum here. So we can say max at f of -1, which equals 3. And then we had a minimum at f of 2, which is equal, oh, sorry, not f of 2. It's not there. That's a relative minimum. We're here at -3, f of -3, which is equal to -1. Okay, there's our max and our mins. Okay, and then down here where it says statement for the absolute extrema, this is where they wanted what we talked about. That goes there. I was supposed to just say yes here. Yes, in this box. Yes. Okay, so let's look at some counterexamples now. Alright, f of x here. Is f of x continuous on the closed interval, meaning including the endpoints? Well, it's not continuous on the endpoints, -3 to 5. It is not, so I'm going to say no. Can we apply the EVT, the extreme value theorem, guaranteeing there's a maximum and a minimum? Well, no, because it is not continuous on that closed interval. Does f of x have a minimum or a maximum value? Yes, I do have an absolute minimum, which is right here. So yes, we do have minimums. Okay, and our statement for this is we have a minimum at f of -1, which is equal to -3. Okay, now absolute maximum. Well, the biggest value is going to occur at the end of our interval here, near f of 5, but it's not included there, so I don't have an absolute maximum. Next, looking at this example here, is this function continuous on the closed interval? Yes, it is. This one is. Okay. Can we apply the extreme value theorem? Well, yes. If it is continuous on the closed interval, we can. And then, does it have a minimum or a maximum? And the answer is yes. The extreme value theorem guarantees it. It does. Now, visually, maximum values occur here at the endpoints, and the minimum value occurs here. Okay, so where do we have absolute max? So we can have a max at f of -3, which is the same as f of 3, which is 4. That's the absolute value, or the absolute maximum value. And then minimum at 1. So we have a minimum at f of 1, which is equal to 1. Okay? All right. So, while the extreme value theorem guarantees us that any function that meets the condition will have both an absolute maximum and an absolute minimum, the theorem does not give us any information on how to actually find those values. This is going to go ahead and lead us into our next video where we talk about the candidates test, how you actually find absolute or global extrema. Go ahead, give me a thumbs up, like the video, subscribe for more awesome math videos. See you in the next one.